Hey everyone, today we're going to be doing some midterm review for Math 20-1. We're going to be going over units 1 to 4 from quadratic equations and functions to our inequalities unit and also our rationals unit. So this video is going to be covering just about everything. We're going to be doing a practice test. We're going to be breaking everything down, and all I need you guys to do is just, pay attention, follow along, and I think everything should be good. So, yeah. So let's get straight into it. Alrighty, here we have our first question. We're going to be starting with our quadratic functions unit. So our unit 1 in this case, ignore the chapter 3. I'm not really sure if that's accurate or not. But if it is chapter 3, then yeah, for sure. Okay, anyways, let's get straight into this. So, question 1. Which equation represents a quadratic function that has a maximum value of 7? So the way I like to do this is I want to outline basically the keywords here. So I would say maximum is like the key word here. And that's because, remember, from our first unit, we have two types of parabolas, right? We have one that can look like this, with a highest point being a maximum. So this vertex right here is going to be the maximum point. And then we have the other vertex which we can have, which is going to be facing up. It has a minimum because has a lowest point, right? So in this case, if it's asking for a maximum, we're looking for our graph that looks like this and also has the maximum value of 7. So it has to be, our vertex has to be like this. Our graph has to be pointing down, and our vertex value has to be 7. So let's take a look at this, okay? So if we're looking for a maximum value, typically it's in relation to y. So we're looking for where our y value is 7. So immediately we can cross out these two answers here. Additionally, remember that our a value, right? So our invisible a value here and our a value in this case over here has to be a negative to make our parabola look like this. And if it were positive, then our parabola would open upwards and thus have a minimum, which is not what we're looking for. So no, we don't want our a value to be positive. And since this answer right here has a invisible 1 here, which is positive, this answer is going to be wrong. And this is all by a process of elimination, meaning that the only equation which will give you a function that has a maximum value at 7 is going to be a. And if you're unsure, again, we can go in our calculator. We can test it, right? So let's go negative 3x, x plus 1 squared plus 7. So I'm going to show you the calculator here. And it's going to hit graph. So again, we have a maximum point here, and that maximum point is at 7. So that is how you know you are correct. All right, so which statement is true here, okay? So we're just looking for the one so that means 3 out of 4 options here are going to be false. So that's something we know. So just keep this in mind. And we're examining this function here. So there's a couple things we have to look at. Remember, our vertex form is going to be y equals ax minus p squared plus q. And since this is a positive 2 here, that means our p value, if we plug it into here, would give us a negative 2. So our p is negative 2 since we have a plus sign. And our q value is equal to 4. And our a value, remember, the one in front, in this case right here, your a is going to be negative 1. So let's look at the options here. So if a says our parabola opens up, so if our parabola opens up, that means it would look like this. And remember, from the last question, we said that when our a value is negative, it opens down. So if our a value is positive, it'll open up. But in the equation that we're given, the a value is actually negative, right? So if it's negative, that means it's going to open down. So this right here is going to look like this. And if you're confused, you can just graph this and see what it looks like. But yeah, it should open down and create a maximum point. So saying that it opens up is completely incorrect. So we can immediately eliminate 2 of our options. From here, we have to see what our vertex is, right? So it says 2, 4 could be our vertex. So the 4 is correct. The 4 is correct. But the difference is the 2 and the negative 2. If our equation didn't have this plus sign here, because if it didn't have this plus sign here, then we would have a positive 2. But since it does have the plus sign, that means we plugged in a negative 2 to get that plus sign. So that means D is our only right answer here. Because our parabola opens down, which our a value means our a value is negative, which it is. Our x value for our vertex is going to be at negative 2. And the y is going to be at positive 4. And these are all correct. So that is how you know you're correct with this question. Here we have number 5, and we're asked to consider the function y equals a x minus 1 squared plus 2. And it's asking us what must be true of a if we want our function to have no x-intercepts. Justify your answer. Okay, so if we're looking for no x-intercepts, that means we don't want our parabola to touch the graph. So it should be, or touch the x line. So it should look something like this. So it should either be above the line or it should either be below the line. But you generally don't want it to be touching this line at all here, because then it'll be an x-intercept. So again, if our point is at 1, 2, because remember the negative 1 is just a 1 here for x value. So our vertex is going to be at 1, 2. On our Cartesian plane, 1, 2 would be like, so let's say this is 1 and this is 2. So it would be like right there would be 1, 2, right? And if we want us to have no x-intercepts, we want our a value, or we want our graph to open up and not down. Because if it opened down, then we would have 2 x-intercepts. But we want none, right? So we want it to face up. And what does that mean for the a value, right? Because we're asking what it has to be true of the a value. That means that the a value has to be a positive number. Because remember, when a is positive, then we have our parabola which opens upwards. And when a is negative, we have the parabola which opens downwards and creates a maximum, whereas this one creates a minimum. So we want a minimum at our vertex. So a has to be positive. But how can we say this in a different term? Because technically this is right, but there's a way that we can express this so that it's more clear. A has to be greater than 0. So a has to be greater than 0 because any number that's greater than 0 is positive. And the reason it's not equal to 0, because if it were 0, then it would cancel out this whole thing here and we would just get 2, which is a straight line. So it cannot equal 0. But basically this will be your answer for where a has to give us this function with no x-intercepts. And that is how you do question number 5. Alright, we're going to be doing question 6b. So this one is a little bit of a trickier one, and it's a bit of a process to figure this out. So just follow along and just make sure you're actually, keeping track with this stuff. So to begin with, I'm just going to label what are important, or I'm going to highlight our important information here. So what's important is definitely this -6, -1. Our axis of symmetry is definitely important too. And our y-intercept is definitely important. So basically what we're given right now is 3 usable points. So we have -6, -1. Our axis of symmetry. And remember, axis of symmetry is our p-value of our vertex. So our axis of symmetry is going to be -5, q. So this is going to be pq, where this is our vertex. We don't have q yet, but we do have our y-intercept. And our y-intercept is where x is equal to 0. So remember that we have 0, comma 71 as the x-intercept. So what I'm going to do now is I'm going to use the point -6, comma 1 to find our a value, because we don't have our a value. So we have y equals ax plus p squared, or sorry, ax minus p squared plus q. Now what we can do is we can actually plug in our values. So I'm gonna label this. I'm gonna label everything here. We have -6 as our x, -1 as our y, -5 as our p, and our q is going to be our unknown. So what we can do now is we can plug it in. So -1 is y is equal to our a, which we're looking for right now. Our x value we don't know, or we do actually, sorry. Our x value is -6 minus our p value, which is -5, plus our q value, which is unknown right now. So from here, what we can do is we can simplify this expression here. So we have -1 is equal to, and I'll put this in our my calculator over here. Make sure you're putting in all the brackets as always. And you're gonna get a times 1, so just a basically, plus q. -1 equals a plus q. So now that we have two variables, we have to isolate for one of them. Whichever one, I'm pretty sure it doesn't matter. But what I'm gonna do here is I'm gonna isolate our a value. So I'm gonna subtract q from both sides, and you're gonna get -1 minus q is equal to our a value. Now what we can do is we're gonna use our y-intercept in our equation to find our new or our q value. So remember this formula for later, because we're gonna be coming back and using this. -1 minus q equals a. So remember we have y equals a x minus p squared plus q. And we're looking for, so we've used this point here and we've used our vertex point. So the only one that's missing we haven't used so far is our y-intercept. So we're going to plug in our y-intercept now. So our y-intercept is going to be y is equal to 71. Our a, remember we just isolated for a, so we're going to plug in this value for a here. So -1 minus q times our x value, so x in this case is 0, minus our p value, which is -5, remember, squared, plus our q value. We've gone from two variables to one by plugging the other one into this equation here. So what we can do is now we can isolate for q. So we have 1 minus q, and then we have 0 minus 5 squared gives us 25. So equals 25 times -1 q plus q. So from here, what we can do is we can distribute this onto here and get 71 is equal to -25, or 25 times -q gives you -25q plus q. From here, we're going to add 25 to both sides, and you get 71 plus 25 equal to 96. And this cancels out, equals -24q when we combine like terms. So now we're going to divide both sides by -24 to isolate for our q. Because we've combined this like terms here. You're going to q is equal to -4. So a lot of work just to find one variable, but now that we found -4 is equal to q, how can we find a? So technically you could use this formula here and use all your newfound points once again. But however, remember we made a formula to find our a value very easily, and it's -1 minus q is equal to a. So -1 minus our q value is now -4, and that's equal to our a value. So -1 minus -4 gives you +3, and a is going to equal 3. So now we've found all of our variables successfully, and this one was a bit of a tricky one. It's a lot of steps, but basically you're just trying to use every single point to find the variables you're missing, because we were missing a and we were missing q, but now we have both. So now we're just gonna rewrite our equation out. So we have y equals, now that we have a, we have 3 x minus our q value, which is -5, squared plus our q, or in this case it's going to be -4. And now we can simplify, and you're going to get 3x, and this gives you x plus 5 squared -4. And that is how you solve this problem. So again, this equation is a bit of a tricky one, but this is, I don't think this would be a testable question. It's pretty long, and honestly, but it's just for understanding, right? So we have the axis of symmetry equals -5. So basically, this is the equation which models the point, or it goes to the point -6, comma -1, -5, and has a y-intercept of 71. And if you want to check that all on your calculator, you sure can, but I'm not going to do that right now. But this is how you do this equation successfully. So if you've done that, that is a good point. This is a good point to be if you're able to do this. So just give yourself a pat on the back, because this one's pretty hard. Moving on. All right, so we have our unit 2 now. We're asked to find which binomial is a factor of this equation here. So to begin with, we have to factor this. So to factor this, we have to do our AC method, or our decomposition. So we're going to get 2 terms that multiply to -42. And we're going to get 2 numbers that add to 11. So what are 2 numbers that are going to multiply to -42 but add to give us 11? So what I'm thinking here is probably, so the 2 numbers here are going to be 14, -3, because 14 times -3 gives us -42, but 14 plus -3 gives us 11. So now that we found our 2 numbers, what we have to do is we have to split our middle term. So we have 2x squared plus 11x minus 21. We're going to split this middle term into the 2 numbers we just found. So we got 14x, and we have 3x, remember. So now that we split this, we have this and this. And that's what that should look like. So now we have to group these 2 boys up and just factor out what's common between these 2. So in this case, it'll be a 2x, a 2x, and x plus 7. And in this, on the other side, you're going to get -3, x plus 7. So you gather these 2 groups, and you're going to get 2x minus 3, x plus 7 as your factored form. And if we're looking here, which binomial is a factor? 2x minus 7 is not a factor, 2x plus 3 is not a factor, x minus 7 is not a factor, but x plus 7 is. So that is going to be one of your answers there. That's going to be the answer to that question. You're just going to have to factor that. It's a bit of an easy one, but we'll take what we can get, right? So for this question, which values of k of this equation will have no real roots? So remembering, we have a certain formula for this, right? So in the quadratic formula, what's inside the square root is this little thing right here, b squared minus 4ac. And this is called the discriminant. Basically what it is, it tells you whether we have a equation with 2 roots, 0 roots, or 1 solution. And if it has 1 solution, then this will be equal to 0. If it has no real solutions, it'll be less than 0. Because remember, we're taking the square root of this number. If it's giving us a number that's less than 0, you can't take a number, you can't take the square root of a negative, right? So basically, that's why we set it less than 0 if we don't want any real solutions. Because if it was a negative number and our discriminant gave us a negative number, then we'd be square rooting that, and that would give us absolutely no real solution. So again, it's less than 0 if it's negative, or no real roots. And then it's greater than 0 when it's 2 solutions. And it's equal to 0 when you have 1 solution. Or 2 equal solutions. Which we should recall. 2 equal solutions just means 1 because it's the same number. But don't worry about that too much. So basically, a lot of yapping, but let's get it straight into our discriminant. So we have the formula b squared minus 4ac. You're going to have to remember this, and this is for determining how many roots there are in a given equation. So just be sure you're comfortable with this. And you're probably wondering, like, a, b, c, like, what does it even mean? Remember, we have to label this a, this b, and this c. We're just looking at the coefficients of x. So our a value is going to be 1. Our b value is going to be -6. And our c value, since we don't have an x or anything there, we have k. So let's replace this. So we get -6 squared minus 4 times our a value, which is 1, times k. And now you're probably wondering, what do we do, right? Since we're looking for no real roots, that means we're going to have a negative square root. So it's going to be less than 0. You get 36 minus 4k is less than 0. You add 4k to both sides. And now you divide by 4. And you get k is less than, or k is greater than, yeah, k is greater than 9. Or it could be written like this. So, whichever equation has this being true will give us the right answer here. So, we found the solution for where we have no real solutions, okay? So, now we're going to look at our answers. So, B says that we have 9. And if we plug this in for a value of k, 9 is equal to 9. It's not greater than 9, so this is not going to be true. We have 5, which is greater than 9. Is that true? Nope. And you have -9, which is greater than 9. Is that true? No. But when you plug in 36, 36 is indeed greater than 9. So the value of 36 would give us no real solutions. So question number 6, we have to identify the error and write the correct solution to this equation. So let's see where the student went wrong. So I'm gonna label this A, B, and C, as they should have. So they plugged in -5 for this. This is good. This is good. For AC, this is plugged in correctly. So this part of the process is true. So let's see where they went wrong. I think it might be in this step here. So they simplified the 5 correctly, simplified the denominator correctly, but did they simplify the root correctly? Let's plug all of these values into our calculator to see if we're getting the same thing. So square root of -5 squared minus 4 times 3 times -2. That gives us 7. So they did this part wrong. So this step is the incorrect step. So step 3. And to find the real solutions, we're just going to plug in our answer for roots in place of this on root 1 here. So we're going to put 7 instead of that. And we're going to get 5 plus 7 over 6 as one of your roots. So you're going to get x is equal to 2. Now we have to do the negative case. So 5 minus 7 over 6. And you're going to get -1 over 3. So those are going to be your correct answers. And step 3 is going to be the part where this person messed up. Alright, here we have Unit 3. We're going to be doing systems of equations and inequalities. So these are very common test questions that they're going to ask you. They're going to give you a graph, and then you have to correctly identify which equation represents the graph, right? So to identify this, remember that when we have a dotted line, what that means is we cannot equal. So it has to be one of these two signs. But when we have a straight line, like a fully filled line, we can be equal to any value on this graph. Dotted line means it cannot equal. So we're going to cross out the ones that have this or equal to sign on the bottom, because immediately those are going to be bad choices. So now we're left with two options here, right? So we either have this side of the equation is greater than this side, or the opposite. So how do we figure this out? So the way I like to do this is, again, you're going to do a test point. So I'm going to pick a test point right here. So 0, 0 is always a nice test point to be using. So let's test. Let me delete this real quick. Yeah, so the test point 0, 0 is always a nice point to be using. So in this case, we can. And you have to know what you're looking for, right? If our inequality gives us a false answer, then that'll be the right answer. Because if it were true, then this part of the graph would be shaded, which is not what we're looking for. 0, 0 is not shaded at all. So we want this to be, we're looking for it to be false. So just write false is right answer. I know it's a little confusing because like the opposite, right? Like false, like you expect that to be wrong, but it depends what you're looking for, right? If you were to test this point like out here, whatever this is, like 2, 1, you're looking for that to be true because it's shaded. So you just have to be like kind of aware of what's going on here. But yeah, we're just looking for 0, 0 since it's nice and easy, but also because we want to be false here. So enough with the yapping, let's get straight into it. So x is 0 and y is 0. So -0 squared plus 0 is greater than 0 minus 2. So 0 is greater than -2. Is this true? Yes, it is. So true. But again, we don't want this to be true. Remember, we're looking for it to be false because this is not shaded. So we're going to cross out this answer here. The best answer, therefore, is going to be D. By process of elimination and using test points, we can determine this. Question number 2. We're asked to find which of the pair below is the solution to the system of equations. So, best way I would like to do this is, I'm not going to solve it. That's going to take a lot of time. What we can do is we can just honestly test each point and see which one gives us a good answer. So if we're plugging in x for both, we're just kind of technically verifying the solution, right? So if we're plugging this point into here, it needs to be correct. Left side has to equal right side on both. And it has to do that on both equations actually. So basically, when you're plugging in a point, the point that you're plugging in, the left side has to equal the right side of the equation. And if it doesn't, then your solution is going to be incorrect. So, the way I like to do this is we're just going to plug in 1 comma negative 1. So our y is equal to 1 plus 4 times negative 1. And that gives us that left side equals right side for d on our first equation. So that's good. Now we have to check our second one. So our left side is going to be negative 6 times y. And we're testing the point negative 1 comma 1. So y is equal to 1. So negative 6 should equal 4 times negative 1 squared minus 3. So 4 times negative 1 squared minus 3. And that gives us 1. So left side does not equal right side on our first equation here. So D is a bad answer. So now we can test the other point. So we have 1 comma negative 3. In a fraction like this, I like to store as a variable. So I'm going to store this as x here. So I also have negative 7 over 9 here. And I'm going to store this as our variable y. So now it's nice and easy. I can just plug in this whole equation. So 3y plus 4x. And that gives us negative 1. So in our first equation, we have a true solution. So this is looking good so far. And now we have to test the other equation here. So the bottom one. So we have negative 6y. And that gives us our answer of 14 over 3. So now our right side has to be equal to 14 over 3. So 4x squared minus 3. And it is not equal to 14 over 3. So C is a bad answer. Moving on, we have question B. We have negative 0.5, which I'm going to store as x. And again, I'm just testing all of this in my calculator. And we have 1 over 3. I'm going to store as our variable y. So 3y plus 4x is the equation. And you're seeing if left side equals right side. In the first one, again, it does. Looking good. Now let's try the other one. Negative 6y. That gives us negative 2 as our left side, which has to be equal to our right side. So let's plug in the right side. So 4x squared minus 3. And this should give us negative 2. And it gives us negative 2. So this is a solution where it gives left side equals right side on both of our equations. So therefore, B is the best answer there. Alright, so here we have question number 3. We have this question, what tells us the base of a right triangle. So this part of the triangle is our base, and this would be the height of the triangle on the left, this height here. So the base is 8 centimeters shorter than twice the height. So basically 2 times our height minus 8 is going to be equal to the base of our triangle. The area has to be less than 192 centimeters. So if it's less than, then our triangle's area can't equal this, or it can't be greater than this. So you're probably wondering what that means, right? So we're asked to write an inequality to represent this equation here. So the way we do this is, remember, 192 is equal to our area. What is the area of a triangle equal to? Base times height divided by 2. Do we have our base and our height? Most definitely we do. So we have h times our height over here, which is 2h minus 8. And that's going to be divided by 2. However, we don't want this to be equal to since we're making an inequality problem. So what we're going to do is we're going to get rid of the sign and look what it's saying. So it's saying we have to be less than. So our area dimensions have to be less than 192. So let's make it less than 192. There we go. Now that we've done that, we have to solve the inequality. So now let's begin to solve this. So let's go in here, multiply both sides by 2. They're going to get 384 Cool. Now that we've done this, our equation now becomes this. So what we can do is we can FOIL, or distribute this h onto the rest. Get 384, and this equation is going to be less than, because this represents the base and the height. So we get 2h squared minus 8h. From here, what we can do is subtract 384 from both sides. This cancels, and you get 0 is greater than 2h squared minus h squared, or minus h, minus 384. And this is going to be your equation here. Alright, from here, I'm going to divide everything by 2. So we have a greatest common factor of 2. Get h squared minus 4h minus 192. Now, what we can do is we can use our quadratic formula to find our two solutions. So we get square root b squared minus 4ac all over 2a. Now I'm just going to plug and replace. So our h is going to be equal to 4 plus or minus the square root of negative 4 squared minus 4 times 1 times 192 all over 2 times 1. So once you plug that all into your calculator, you get your two solutions as 16 and negative 12. From there, remember, when we have dimensions, we can't actually have dimensions that are going to be, negative. So h has to be greater than 0. So that's one of the restrictions on this equation, because our dimensions can't be negative. So you're probably wondering, like, is this an extraneous root? Like, what do we do with this? So what we have to do is, since we're looking for two possible set of measurements, we have to find the inequality that actually makes this equation true, or this equation true right here, because we have to actually fulfill, the criteria of being less than 192, but still having the base 2 times the height minus 8. Okay, so I'm going to show you what that actually means now. Remember that if you watch my inequalities video, I taught you guys how to graph with your calculator. And if you didn't, that's fine. I'll go over it again. Basically, y is going to be on your left side, remember, because when you're graphing, all these y's are on the left side over here. And since we have a y being greater than, because y is on the left side, we're putting the 0 as a y. We're going to have to graph this above the line. If it was less than, then we would have this bottom triangle here. But we don't have the bottom triangle. We have the greater than. So we're going to be plugging in our calculator this right here. So this y with the greater triangle equals h squared minus h minus 192. And now we're going to look at this. So y is greater than. So we got this good top right triangle here. Press OK. Now we're going to put x squared minus 4x minus 192. And since our inequalities region is in between the 2 points, that means our solved inequality would look like this. Less than or equal to x, less than or equal to 16. This is stuck in between. However, remember, our height has to be greater than 0. Negative 12 is not 0. So our new inequality is going to be this. And these is going to give us the 2 dimensions that we need to have this question answered. So let's 2 possible set of measurements, right? So I can pick any number between 0 and 16, and that'll give me an answer which is correct here. So let's try this. So if I pick, let's say, the height, and I pick a height of any number between 0 and 16, so this should be not equal to. Yeah, but any number that's not 0 or 16 here. So let's say I pick 15. So our height is 15. And our base, remember, it's 2 height minus 8. If our height is 15, we have 2 times 15 minus 8 as our base. What is that? 2 times our height is 15 minus 8 gives us 22. 15 times 22 divided by 2 should be less than 192 because our area, remember, is supposed to be 192, and we have to make sure that our inequality region is actually correct. So 2 times 15 minus 8, it gives 22, but 2 times 15 over 2 gives us 165, and 165 is less than 192. So 15 and 22 is a combination that works. So again, I'm going to try another combination since we have to list 2 possible measurements here. So any number between 0 and 16 is good for our height. So let me try 14 now. So if I try 14, our height is going to be 14. So 14. And we're going to have 2 times our height, which is now 14, minus 8 is equal to our base. Base is now equal to 20. Does this work? Let's try it. 14 times 20. Sorry, 14. Let's try it now. So 14 times 20 divided by 2, because that's the area of a triangle, gives us 140, which is going to be less than 192. So 14, and now 20 is a possible combination. And there's any combination here. So basically you have any combination between this range here, which will give you an answer that is correct. This one is a bit of a tricky one, but as long as that sort of made sense, I hope that helped. You understand that? Yeah. I think you guys should be fine. Alright, so here we have question number 4. Or number Alright, so here we have question number 6, and what it reads is a skydiver jumped from an airplane. His height, h in meters above the ground, t in seconds after jumping, is modeled by these 2 equations. So we have this one, which represents the height before the parachute was opened, and the height after the parachute was released. We need to find the intersection between these 2 points to determine how long the skydiver was in free fall, because this first graph is going to be a parabola. And typically, I think it's going to look like this. And the other point is going to be a negative slope linear line. So basically, we're looking from this point to this point, because remember, we have to have a positive time and a positive height. Let's ignore this part then. And we're just looking for basically the intersection point to see how long this skydiver was in the air until the parachute was released. So the parachute released is any point after this intersection with the linear line. So we're looking for one specific point of intersection here. So there's two ways we can do this. We can do this with our calculator, or we can do it setting these equations equal to each other. The way I'm going to do it is I'm going to do it with my calculator. So I think it's good that we are able to do these calculator skills. So we're going to put our first equation, -4.9 x squared plus 5,000. And then we're going to do the other equation, which is -4t. So -4x plus 4,000. And we're going to try to find the intersection points. So again, this is going to be a really, really large graph. So what you're going to need to do is you're going to need to be zooming out. So we have the two x-intercepts here, but we don't really need that right now. So again, just know how to zoom out with your calculator and find the points of intersection if you're using your graph here. So again, this doesn't really tell me. I'm going to assume the point of intersection is above, because remember, we want to have in our height, which is positive. Again, you're just fiddling around here until your calculator, gives you a result which you actually like. So I think we've found our 2 points now. So what we can do is I'm zoomed out a little too far. So what I need to do now is I need to zoom in at the top here. I think there's only one point of intersection, so that's very telling. If there's 2 points, usually it's a little more confusing, because you have to be able to make your judgment and decide which one best answers your question. It can be a little hard sometimes. So again, I'm gonna go second trace and intersect. Now we're gonna find the intersection between these 2 points. So I'm gonna get just about on the dots, and we get 14.6 seconds as one of my answers. And now we have the other one, which I'm going to assume is going to be negative. So we're not going to use that other answer, but if you wanted to find it, it would be over here. -13.8. -13.8 is not helpful here. And we're looking for this to the nearest tenth. So we got 14.67, I think it was. So to the nearest tenth, our answer should be 14.7 seconds. So now, to the nearest meter, how high was the skydiver above the ground before he opened his parachute? So before, we were just looking for the distance, right? Because x is usually the distance, or in this case, it's the time that it took him to open his parachute. Now we're actually looking for the vertical distance. So the way we do this is, remember, we got 14.7 equal to our t, and we're looking for the same point. We're looking for before he opened his parachute, right? So it's the same point. So if our 14.7 is equal to the time that it took, we can actually plug it into our equation to find our time, or our height. So we're going to go into this equation, because this is the equation that helps us find the height before the parachute was opened. Remember, we're looking for that right now, right? So what was the height before the parachute was opened? So this equation is perfect, because we can use this. So if we have our time as 14.7, our height, all we have to do is plug in that 14.7 here. So 4.9 times 14.7 plus 5,000 gives us our height. Put this all up in your calculator. You're going to get 39,041.1 meters as your height here. And that is how you solve this question. Alright, rational equations. How do we find the NPVs? Remember, NPVs are where our denominator, values that give our denominator equal to 0. Remember, when we're dividing, we typically don't want to have our denominator go to 0, because then it would be undefined. So all we have to do is NPVs, we're going to look at our denominator, so our lower part of our fraction, and we're going to factor this. So x squared plus x minus 20, two numbers that multiply to negative 20, and add to give us 1. This should be 5 and negative 4, 5 and negative 4. And since we don't have a coefficient in front of the x term, you can factor by inspection. So I do x plus 5, x minus 4. And now you set this both not equal to 0. Since this is an NPV, we don't want it to be equal to 0, because again, if we're dividing by 0, big problem. Set each individual bracket not equal to 0. And subtract 5 from both sides. So x is not equal to negative 5. X is not equal to negative 5. And x is not equal to 4. So whichever answer has negative 5 and 4 is going to be true. So the answer to 1 should be D. Alright, so question number 4. Here's the student's solution to simplifying the quotient of two rational expressions. Identify the errors in the solution. Write a correct solution. So, how do we do this? Okay. We're looking how they simplified this. So, this factors into plus or minus 6. This is correct. They factored this correctly. And they took the reciprocal, which is good. So far, it's looking good. However, let's take a look at where they messed up. Since they're multiplying, they cross out the x plus 1 and x minus 1. X minus 6 and x minus 6. So basically what this should have gave us is x plus 6 over x minus 3, or x plus 3. And that would have been our simplified version. However, they added this random square here, so the error in this process is going to be right here. Additionally, I think the NPV is right. Yeah, so error is going to be here. And also right here, because our NPVs are more than this. Remember, we have this 1 here, so x plus 1 cannot be equal to 0, and x minus 6 cannot equal to 0. So x cannot equal negative 1, and 6 as well. So that is also another error of this equation. The way you solve this, I'm not going to do all that. But yeah. Alrighty, question number 2 here. We're looking for an equivalent expression. So what we're going to do is we're going to simplify this expression here. So the way we do this is we have 3x. And there's nothing we can factor so out of the numerator, but on the bottom, we notice that there is a common factor of 2. So let's factor out a 2. You get x minus 3. Plus 9 over, and usually when you're factoring out something, you're going to factor out whatever is in front of x. Since we have a negative 2, we're going to factor out that negative 2 there. So we're going to get so 6 divided by negative 2 is negative 3 plus x. Or in other words, x minus 3. So now that we have this, we have to find an LCD so that we can actually add these fractions. So our lowest common denominator here is going to be negative 2 x minus 3. To make this negative 2, we're just going to multiply both sides by negative 1, or the numerator and the denominator by negative 1. So negative 1 over negative 2 x minus 3, 9 over negative 2 x minus 3. Effectively, what this turns into is negative 3x plus 9 negative 2x minus 3 2x minus 3. Okay, cool. Now what we can do is, since they're actually the same denominator now, we can actually begin to add. So now if we add these, since they're not like terms, you're going to get negative 3 x plus 9 over negative 2 x minus 3. And this is not fully simplified yet, because again, we can factor out this numerator. So what we're going to factor this to is going to be a -3. We're going to factor out the -3 since it's in front of x. We're going to get x minus 3 on top over -2, x minus 3 on the bottom. And you're going to notice we can actually cancel these terms out. And since there's a negative sign in front of both of our numbers, that cancels out too. And we're left with just 3/2. So that is our simplified version of our question here. So 3/2 is going to be one of our answers. So get rid of this -3/2 because that is not one of our answers here. And for the NPVs, what we have to do is we actually have to go back to the original equation here. So we have 2x minus 6 cannot be equal to 0. And remember that these are equivalent, so you're going to get 2x cannot equal 6, and x cannot equal 3 as your one NPV. So 2/3, or 3/2, sorry. So these will be your answer here. Whichever one has that will be your answer, and in this case, it will be B. So that is how you solve question 2. Alright everybody, thank you so much for watching. I hope this video, helped prepare yourself for the math midterm. I hope everyone does very well. I hope you guys learned something from this video. If you want more in-depth explanations and me doing word problems and things like that, there are videos on each individual unit, and you can watch some of the word problems that I'm doing to, further help you understand, because this was just very brief. I had to go over basically the easy stuff and the simple stuff right now. But if you want to go into depth, definitely do consider checking out my other videos. But other than that, if you guys had fun, just leave a like, I guess, and that'll make me happy. But yeah, good luck everybody. See you guys later.